Hello everyone, this is our second exercise, and the aim of our exercise is to use the given data set to build a decision tree based classification and to analyze difference of outcome with or without pruning. So here we start up our new exercise with the help of a data set iris, which is found in the samples. We take it, we drag and drop this data set over here, then we use decision tree operator. Okay. We connect it to the ports. Now if we run it, okay, when we run the process, we get the result as this. This is the tree generated. This is the decision tree. Actually, decision tree is a tree-like graph in which the tree is inverted in shape. That is, the root here, A3 is the root, and it is present at the top, while the leaf nodes are present at the bottom. So here the whole main idea of the tree which we have derived is that if we have a new instance with us and we want to classify it, what happens is first we come to this root node, that is A3, and we do a if check. That is, if the value is greater than 2.450, it comes to A4. If it is less than or equal to 2.50, then it is classified as iris setosa. So when it comes to A4, it further uses a if check. It's like if it is greater than 1.750, then it is classified as iris virginica. Whereas if it is less than or equal to 1.75, it is classified as, it goes to A3, and further it has more check, and it goes on till it is classified. So this is the whole idea in this tree based graph. Now further what we can do is we can go to the, we here in the right hand side we have parameters. Here we have a criterion which has gain ratio, information gain, Gini index, accuracy, etc. and maximal depth. This is used because normally human beings cannot read or cannot understand a tree beyond the depth of 10 to 20. So the reasonable value which we give over here is 10 to 20. And then we have confidence. This value is relevant to pruning. So what is pruning? If you think it's reducing the tree, the size of the tree by removing some of its resources, that is cutting down the trees. And here we have leaf size. We can give accordingly the number. Here we have minimal gain. It's like sometimes it is not necessary to allow the tree to grow into a large depth, because if we don't have any gain from it, it is not necessary to let the tree grow. So with this minimal gain, we can adjust the growth of the tree. For example, if we have a data set and if the tree growth is not so much, then what we do is we reduce the minimal gain value and allow the tree to grow. And then now as this data set iris has only few attributes, so what I'll do is I'll delete it and I'll use yet another data set which is present here, sauna data set. I'll drag and drop it over here. I'll do the connections. If I run it, I get the tree like this. This tree actually is a bit more complex than the tree that we previously saw, because it has almost 60 attributes in it. Now we go to the design. So here, what else we can do with this tree? Let us go on further with discretizing the tree. Discretizing by frequency. So we have this over here. We'll do the connections, connecting the boards, and we'll give the number of bins as 3. And if we run it, yes, we get a tree of this kind, and yes, it is really huge tree. It is kind of very big. So we might have a question in our mind that whether the tree we developed is good or bad. So to find the answer for that, we want to check the accuracy and performance level. So to do that, we can do it using cross-validation. Cross-validation, for that we need a cross-validation operator, which we have over here. So as we bring the data set over here into this validation mode, we need 2 more operators. Apply model operator, as well as we need performance classification operator. We do the needed connections. Yes, it's all connected. Now let's go back to the process. So first what we do is we remove the discretize operator and just check the performance by using validation factor. When we run it, yes, we have the accuracy over here is 62.12%, and we have a true value of 49 and 80, which is not bad, but we have errors of 48 and 31. And the accuracy is also low. So what we do is we go back to the validation, we include discretization factor as well. Discretize by frequency. We give the connections as required, and now if we run it, yes, we can see that previously we had a accuracy of 62, and now the accuracy has increased to 72.10 when we included the discretize by frequency as a operator. And also the error values 3523, it's also reduced, so it's a very good accuracy as compared to before. And we can further change the validation, number of validation, and by changing this number of validation we can improve our accuracy. For example, if we run it, we get the accuracy 71, so it has reduced. So we go back, we change it further to, for example, 20, and if we run it, yes, so it has decreased to 70.27. so actually we had a better performance at number of validation 10. So similarly, if we change this value, we'll arrive at a point where accuracy is better. So what we find from this is we can check the performance by using 2 ways, either by changing the parameters of the decision tree or by using this discretize operator. So in this way we can check the performance and accuracy, and it helps model the tree better. So what we have done so far is we have first we took the iris data and decision tree operator. We looked into how the tree is created and how to classify an instance when we get it, and then I moved on to taking a data set on Sonar, that is a mine and rock data set, and then I showed you how to check the performance and accuracy of it. So I hope this video was useful to you. Thank you for watching.